All right, hello there. This lesson is on writing vertex form or from standard form by a method we call completing the square. And the steps for that method are shown here, but they can look rather complex. So we're going to go through an example and see how it works with our functions that involve numbers. So for this problem, we are going to write the quadratic function in vertex form. And then we have to make sure that before we say we're done with the problem, that we also then identify the vertex and whether it is a maximum or minimum. So the first thing that we need to realize is that our -5 is not going to help us create the perfect square trinomial we need that creates in our vertex form that x minus h quantity squared structure. So we need to create a perfect square trinomial, and this number is not going to help us. So we're going to get it out of our way using our algebra, and we're going to add 5 to both sides. So now what we have over here is f of x plus 5. Looks a little weird because we're not used to writing a function plus something, but that's what the math says, so that's what we're going to write. Equals, and our negative here we know means -1 times x squared plus 6x. Now, the procedure we use to help us figure out what number we do need to create a perfect square trinomial only works when our a value is +1. So if our a value is anything other than +1, our second step is to factor that number out. So here our second step is to factor out the a value of -1. We've learned that when we factor out a negative that it changes the signs. So this would become a +1x squared, and our +6x would become a -6x. You should always double check using your multiplication skills to make sure that what you have out here, your a value, times each of these equals what you started with. This over here on the left side is still f of x plus 5. So now in our third step, we are going to figure out over here what we're going to add after that -6x that will create a perfect square trinomial that's eventually going to become that x minus h quantity squared part. And the way we do that is we take our b value here of -6, we divide it by 2, and then we square that number. So -6 divided by 2 is -3, so we are squaring -3. -3 times -3 would be +9. Now in algebra, we always have to balance our equations. So that means that if we add something over here on this side of the equal sign, we also have to add something over on the other side that will make the equation balanced. And it's not actually going to be a 9. That's what you have to be careful with, because the 9 is inside parentheses. And if we remove the parentheses, we'd have to distribute the -1, and that would actually become a -9. So what we actually have to add to the other side is our 9 times that -1, which will be -9. So it comes from 9 times -1. And I encourage you to put the arrows in your notes and beneath this what we multiplied to get that number so it's clear where that came from. All right, we're getting close to being done now. So in our next step, we are going to add these numbers together. So +5 and -9 would be -4. So that's going to give us f of x minus 4 equals. And over here, we now have this perfect square trinomial that we will be able to factor into a quantity squared. Now, I would recommend at this point, until you get comfortable with it, that you factor it normally first. So you factor into 2 binomials, but you should expect those binomials to be the same as each other. The factors of x squared we're going to use are x and x. And then we need 2 factors of 9 that will help us get this -6x. So we need to realize they would both be -3. So -3 times -3 is +9. -3x plus -3x is our -6x. So this becomes x minus 3 quantity squared. All right, one more step and to get it into our vertex form, and that is going to be to undo the subtraction right here and add 4 to both sides. And this is going to become our k value. So now what we have is f of x equals, and instead of writing -1, I'm just going to use the negative sign because that's how we normally see it. It's just a negative sign that means -1, so negative and then times in parentheses x minus 3 quantity squared, and then the plus 4. And there then is our vertex form. And then we can't forget there was a little bit more to the problem. Remember, it wanted us to identify the vertex and whether that vertex is a maximum or minimum, which is two things we've already learned how to do. So our vertex, our h value would be the opposite of our -3, so that would be a +3, and the 4 is our k value, so 3, 4 is our vertex. Whether it's a maximum or minimum, remember, it depends on whether we have an x-axis reflection, and because a is negative, we do, so that means our vertex is a maximum. And now we are finished with the problem. All right, we are going to look at a second example. Here's our function. So again, in order to create our vertex form, a big part of that is creating that perfect square trinomial that will become the x minus h quantity squared part. So we have to realize this -3 here is not going to help us. So because it's not going to help us, we're going to move it out of our way. And so we're going to undo that -3 by adding 3 to both sides. So we now have f of x minus 3, sorry, plus 3, not minus, f of x plus 3 equals 3x squared plus 24x. Now here's a part, and this is where you've got to make sure you're practicing and reviewing this procedure for it to stick in your head, because it's very different from anything we've done before, and it's got quite a few steps. So now we have to realize that the procedure we learned to figure out what number we do need to create a perfect square trinomial only works when a is 1. So if a is anything other than 1, our second step is to factor out the a value. So we're going to factor out our a value, which is 3. And so remember, when we factor, it's like we're dividing. So you can look at it as you're taking your 3 divided by 3, which gives you 1x squared. Or you can think of what times 3 gives you 3x squared, which would be x squared. This is like 24 divided by 3, which is 8, giving you plus 8x. Or you can think what times 3 equals 24 to get your plus 8x. So now we are going to figure, so we have that, and this over here is still f of x plus 3. So now the next step after this is focusing over here now on this side. We are now going to be able to figure out, because this is now a 1x squared, so now we can figure out what number to add after the 8x that will create a perfect square trinomial. And again, our procedure is to take our b value, which is this positive 8, divide that number by 2, and then square that number. So 8 divided by 2 is 4, and 4 squared is 16. The other thing we got to be careful, we have to remember, is that in algebra we always balance our equation. So the moment we added to this side, we have to figure out what to add to the other side to balance the equation. So we've got to figure out what to add after the f of x plus 3 that will balance. And you have to realize it's not going to be that 16, because that 16 is inside parentheses. And if we removed the parentheses and distributed the 3, we'd actually get 3 times 16, which is 48. And that's really what we've added over here on this side. So we always have to take our number here times our a value, which is 16 times 3. And that is what we're going to put here, which is 48. So we're doing the 16 times 3 in that case. All right, so now we would be to the point where we can add these two numbers together, and 48 plus 3 is 51, so we get f of x plus 51. And we can now factor our perfect square trinomial into its quantity squared form. This is going to become our x minus h quantity squared part. So again, if you get to the point where you can figure this out without doing the two binomials first, that is okay. Just be careful with your signs. So the two factors of x squared we want to use would be x and x. And then we need two factors of 16 that will help us get this plus 8x. So we need to realize that would be positive 4 and positive 4. So we get plus 4 and plus 4. And then you can check it. So you got your x squared, 4x plus 4x is your positive 8x, 4 times 4 is 16. So that means this becomes x plus 4 quantity squared. We are almost there. We have one more step. And that is to undo this addition. So we're going to subtract 51 from both sides. And that's going to become our k value. So our vertex form is going to be f of x equals 3 times in parentheses x plus 4 quantity squared minus 51. So that's our vertex form. And again, we can't forget there was that second part to the instructions to identify the vertex. Our vertex, our h value would be the opposite of this plus 4, so it would be a negative 4. And then the negative 51 here is our k, so that's our vertex. And we have to say if it's a maximum or minimum, which depends on if there's an x-axis reflection. A is positive, so there's no x-axis reflection, which means our vertex here is a minimum. Now the problem is finished. All right, we're going to add this third example to our notes now. This function, same procedure basically. However, you may notice in this function, the a value already is positive 1. When the a value is positive 1 in the original standard form, you in step 2 where you're factoring out a, factoring out 1 doesn't change anything. So you can actually skip that step, or you can just go through the motions and notice that it's not going to change. But other than that, the procedure is the same. So the first thing we're going to realize is toward our goal of creating a perfect square trinomial, this minus 8 is not helpful. So we are going to add 8 to both sides. And over here we now have f of x plus 8 equals x squared minus 10x. So like I was saying, our second step is to factor out a when it's not positive 1. Here it is positive 1. So you really don't have to do that. But if you want to keep all of your steps the same, then go ahead and factor out a as a negative 1. So I'm going to show you that because that way you don't have to worry about, okay, when was I not supposed to do this or didn't have to do this? You could just always just do this until it becomes easier. So our a value of 1, we can factor it out, but factoring out 1 doesn't change anything. So this is still x squared minus 10x. And this is still f of x plus 8. So now we're to the step to where we're going to figure out what we need to add after the minus 10x that will create our perfect square trinomial that when factored will become our x minus h quantity squared. So again, we take our b value, which is this negative 10, and we divide that b value by 2, and then what we get there we square. So negative 10 divided by 2 is negative 5. Negative 5 squared, negative 5 times negative 5 would be positive 25. Then we have to remember that we have to balance our equation. Since we added something over here on the right, we need to add to the left. We have to figure out what are we going to add after our 8 to balance. So again, we take our 25 times our a value, which in this case is 1. So here this time we are going to add 25. Because we're doing 25 times 1, our a value. So now I'm going to add my numbers together, the 8 and the 25. So I get f of x plus 33 equals 1. And then my perfect square trinomial here it would factor into two binomials that are the same. So again, you can do it this way and then write it as the quantity squared. If you're comfortable going right to the quantity squared, that's okay. Be careful about the sign, because x squared we'd use x and x, and for our 25, we'd have to use -5 and -5 if we're going to get this negative 10x in the middle. And we can always check our factoring like we've learned how to do. -5x plus -5x, that's our -10x. -5 times -5 is our 25. So this is x minus 5, quantity squared. All right, almost there. So now I'm going to undo my plus 33. I'm going to subtract that from both sides. That's going to become k. And the other thing that I'm going to do when I rewrite this is I'm going to drop the 1. Since anything times 1 is itself, we don't show when an a value is 1. That's why we see our vertex form is without that 1. So we'd have f of x equals x minus 5 quantity squared minus 33. And that would be our vertex form. And then we want to make sure we don't forget that other part. So we have to identify the vertex. So our h value would be the opposite of our minus 5, so positive 5. Minus 33 would give us a k value of negative 33. And a is positive, so there's no x-axis reflection, so that makes our vertex a minimum. And that finishes all parts of the problem. All right, so that is the last example for this lesson, and you can go ahead and begin the assignment.